Hello everyone. In this video, we'll learn about the production of the AM wave. There are numerous methods possible, but we'll take up the conceptually simplest method and we will be learning it through a block diagram and little bit mathematics. So let's begin with the block diagram. First of all, we consider the message signal or modulating signal, or what we call as the information. We write this as MT is equal to AM sine omega MT, and then we take up the carrier signal CT is equal to AC sine omega CT. Okay, these two signals are added up, so we get XT is equal to MT plus CT. This XT is fed to some square law device. About the square law device, we'll take up a question and you'll understand it much better. Right now, you should just know that square law device has the square relationship in between the current and voltage. Fine. Now, the output of the square law device is given as YT is equal to B times XT plus C times X square T. Got it? And this output is fed to some band pass filter which is centered at omega C. Actually, the band pass filter allows a particular range of frequencies to pass through it and blocks all remaining frequencies. In this case, our band pass filter allows the angular frequencies in the range from omega C minus omega m to omega C plus omega m, and all other frequencies are blocked. Okay, the output of the band pass filter will be an AM signal. So I'm starting the mathematics of this block diagram. Just pay attention. First of all, we'll be taking up the message signal MT, which we will write as AM sine omega MT. Done. Then we choose the carrier signal CT, which is equal to AC sine omega CT. Now these two signals are added up according to the block diagram, which we write as XT is equal to MT plus CT. This XT is fed to some square law device and the output of the square law device is given as YT. YT was equal to B times XT plus C times X square T. Is it okay? Fine. Now I am putting up the value of the XT. So it will be B times AM sine omega MT plus AC sine omega CT plus C times AM sine omega MT plus AC sine omega CT whole square. This can be solved using the A plus B square formula. Okay, so let's proceed further for the calculations. This part will have no change, so I'll write it quickly. Here we'll use the formula. So we should write this as C AM square sine square omega MT plus C AC square sine square omega CT plus 2 C AM AC sine omega MT sine omega CT. Once you should check the things, it's simple mathematics only. Now focus on few things. Here is sine square term, here is sine square term, and here you can see 2 sine A sine B. Anything you remember from trigonometry, how we can simplify these kind of expressions? For sine square theta, we have sine square theta is equal to 1 minus cos 2 theta by 2. Got it? And for 2 sine A sine B, we have 2 sine A sine B is equal to cos of A minus B minus cos of A plus B. So I'll be utilizing these formulas and rewriting the expression. Pay attention. This term and this term will be written as it is, no change. So plus CAM square sine square omega t can be written as 1 minus cos 2 omega t by 2, trigonometry. This will be written as CAC square, and again same thing we will do, 1 minus cos 2 omega ct by 2 plus this CAMAC is kept intact and 2 sin A sin B is simplified. So the expression will be cos of omega c minus omega mt minus cos of omega c plus omega mt. Is it okay? Now, if we check this signal, which frequencies are present in this signal? Omega m is present, omega c is present, 2 omega m is present, 2 omega c is present, omega c plus omega m is present, as well as omega c minus omega m is present. Now we'll be passing this signal through the band pass filter and we'll get the output. So pay attention how we'll do the things. I'm making a diagram for the gain of the band pass filter. Here on the x-axis, let's say we consider the angular frequency, and on the y-axis we consider the gain, and diagram for the band pass filter will be something like this. This frequency will be omega c minus omega m. This frequency will be omega c plus omega m, and the band pass filter is centered at omega c. It means what? The band pass filter will pass frequencies only in this range and remaining all frequencies will get blocked. So if I write these things, which will get blocked by the band pass filter? Omega m, omega c, 2 omega m and 2 omega c. Okay, these frequencies are blocked by band pass filter, and which are allowed? Omega c minus omega m, omega c plus omega m. These frequencies are allowed by the band pass filter, or any frequency in this range will be allowed. Once again, I am explaining the meaning of this curve for the band pass filter. For these frequencies, the gain is low. It means these frequencies are not being passed by the filter. Similarly, for these frequencies, the gain is again low. So these frequencies are also not allowed by the filter. For this range of the frequency, the gain is very high. It means this range is only allowed by the filter. Got the meaning of the band pass filter? You may note it down, and then we'll be taking up 3 brilliant questions to understand all this calculation very well. Okay, note it down. Here is the first question, and you have to choose the correct option. Once you give it a try, then I'll be explaining the things. Okay, the correct answer is the second option. How? Let's pay attention. We require the square law device for the modulator. The meaning of the square law device is this: the graph should look like as a parabola, mouth opening upwards. Got it? Now, the second option is correct, and first option, third option, they are wrong because they are representing some linear device. By the word linear device, we mean that I is directly proportional to V, but we required the square relationship. Note it down, then we'll be taking up the next question. It's a brilliant question, and more than one choice is correct. So pause the video here and try to guess the correct options. Then I'll be explaining the things. I hope you got the correct options, which are A, B and C. Let's see the explanation. Option A says the graph 1 followed by 2. Initially, the graph 1 means this device will allow all these frequencies, and the frequencies above omega c plus omega m are blocked. Got it? Then the signal is passed through this device and it will block all the frequencies below the omega c minus omega m. Then what you are left with? You are left with this range, the frequencies starting from omega c minus omega m and ending at omega c plus omega m. So ultimately our task is achieved. Got it? And the reverse is also true. First, the signal is passed through this kind of filter, then it will block all the frequencies below omega c minus omega m and will allow all the frequencies higher than that. Then the signal is passed through this one, it will block all the frequencies higher than omega c plus omega m. So ultimately the signal will contain the frequencies in the range of omega c minus omega m to omega c plus omega m. Getting it? So this graph is directly correct because for the required range of the frequencies the gain is highest. For amplitude modulator we require this range of the frequency, so its gain is highest, and for remaining frequencies the gain is low. It means they are being blocked by the filter. This is wrong. Why? Because for the required frequency range the gain is very low. This is not serving as a good filter. Got it? So note it down, then we'll go further for the last question of this video. Here is the most beautiful question of this video. So I urge you to pause here and give it your best shot. Although then I'll be simplifying everything on the board. Since the solution is going to be pretty lengthy, so I'll clear up the question from the board and I'll do the mathematics. Okay, so you may give it a try and note it down. I hope you have noted down the question. I'm clearing it up and starting the solution. We know that xt will be equal to m1t plus m2t plus ct. Do you agree? Such kind of things we have done in the starting of this video. m1t can be written as am1 sine omega m1t, m2t is am2 sine omega m2t plus carrier is ac sine omega ct. Okay, in this case we are modulating the amplitude of a carrier using two informations, two message signals or two modulating signals. As we keep on increasing the number of the modulating signals, the process will become complex. Okay, in the previous video we had a single modulating signal and the single carrier. Okay, proceeding further, the yt means the output of the square law device is b times xt plus c times x square t. Do you remember that? So what we need to write? B times of this is xt, so plus c and then square of this term. So is it okay? For doing the computation will require the formula a plus b plus c whole square, which is equal to what? A square plus b square plus c square plus 2 ab plus bc plus ca. I hope you have seen that formula earlier. And another formula which we will require is sine square theta is equal to 1 minus cos 2 theta by 2. So going further, writing this yt in detail, this term will be written first plus c and then a square. A square means this term square. So a square m1 sine square omega m1 t plus c, and then b square means square of this term. So a square sine square t, okay, plus c square means square of this term, c a square sine square omega ct, okay, plus 2 times ab. This we have taken as a and this as b, okay. 2 times ab means a m1 sine omega m1 t, a m2 sine omega m2 t plus 2 times bc. So 2 and bc means a m2 sine omega m2 t, ac sine omega ct, okay. The c was present outside of this entire bracket. So writing the next term, multiplication of these two will give you ca. So 2 c ac sine omega ct and a m1 sine of omega m1 t. Actually it's simple mathematics. If you write the things on the paper, you'll get it very easily. There is nothing complex in that. Now we'll require another formula, this kind of format, 2 sine a sine b. 2 sine a sine b is equal to cos of a minus b minus cos of a plus b, okay. Since there is the shortage of the space, so few things we need to write now directly. You pay attention. The frequencies available, look at this. Here the available angular frequency is omega m1. Next available angular frequency is omega m2. Next available angular frequency is omega c. Here is sine square omega m1 t. So sine square theta can be written as 1 minus cos 2 theta by 2. So the available frequency after simplifying this expression will be equal to 2 omega m1. Do you agree? Then when we operate the sine square over this expression, the available frequency will be 2 omega m2. Then here will be operating again the sine square term, so 2 omega c. Then 2 sine a sine b. 2 sine a sine b, when you simplify, there will be cos of a minus b minus cos of a plus b. So the next frequency which will be available here is omega m2 minus omega m1, and then omega m2 plus omega m1, okay. Then going for this, we will have the frequency available omega c minus omega m2 and omega c plus omega m2, okay. And then going for the last signal, the available frequencies will be omega c minus omega m1 and omega c plus omega m1. Is it okay? So when we are using two modulating signal, we get these many frequencies in the final expression. Here was the shortage of the space, so I have left this calculation. Using these formulas, we are getting the data. Once you write it, then I'll clear up the board and then we'll be utilizing this data again. Here we can see a graph between the angular frequency and the amplitude. These frequencies were available from the previous calculation and I am explaining how to plot this graph. According to the question, omega m2 was greater than omega m1, and from the video of the amplitude modulation, we know that omega c is greater than omega m. Okay. So to plot this graph, let us assign few numbers. For example, suppose omega m1 you consider as 10 and omega m2 you consider as 15. Omega c you consider as, let's say, 10,000. Okay, then 2 omega m1 will be 20, this 2 omega m2 will be 30, and this is 20,000. This one is greatest, so it has been plotted here. Do you agree? Okay, its amplitude is shown in the diagram. Now look at the other numbers. Omega m2 minus omega m1, 15 minus 10, which will be equal to 5. Omega m2 plus omega m1 means 15 plus 10, which is equal to 25. Is it okay? Omega c minus omega m2 means 10,000 minus 15, and this is 10,000 plus 15. Okay. Similarly, we can do calculations here. 10,000 minus 10 and 10,000 plus 10. So now plotting the things will become very easy. This data is the lowest one, so it has been plotted here, and then further data can be plotted very easily looking at these numbers. So we can observe one thing, that left to the omega c, the space is more crowded. If you remember the question, we started with one carrier and two modulating signal. Now if we keep on increasing the number of modulating signals, this space will become further crowded. Then what is the resolution possible? Answer is simple. Increase the omega c as well as the bandwidth. Got it? It was a brilliant question. I hope you understood it. If you have any doubt, fire up the chat box, I'll reply. And in the next video, we'll go through the demodulation. Okay, stay awesome. See you again. Thank you.